You ever stop and think about how the world around us is literally held together, from massive ships to the tiniest, most delicate pieces of jewelry? Well, a lot of it comes down to a single crucial process: welding. Today, we're going to put it time-tested classic head-to-head with its super high-tech challenger. So, first things first, let's get on the same page. What is welding? At its absolute core, it's the art of fusing materials, usually metals, by using some serious heat. You melt them, they flow together, they cool down, and bam, you have one solid piece. It's the magic that literally builds our modern world. Okay, let's start with the original gangster of welding, right? The method that's been the absolute backbone of manufacturing for more than 100 years. We're talking traditional arc welding. So, how does this actually work? Well, I want you to imagine creating a tiny controlled bolt of lightning. An electric arc creates this incredible amount of heat, melting the edges of the metal pieces you're joining, along with the filler material. At the same time, a special shielding gas creates a protective bubble around this molten pool, keeping it pure so you get a really clean, strong bond when it all cools down. You know, the appeal of traditional welding is pretty obvious when you look at it. The gear is relatively inexpensive to get started with, the process is really well understood, and hey, with some practice, you can get really good at it. It's this accessibility that has made it the go-to, reliable workhorse for so many industries for so long. And you can't argue with its versatility. I mean, we're talking about everything from the massive hulls of cargo ships and the steel skeletons of skyscrapers, all the way to the pipelines that stretch across entire continents. Traditional welding is pretty much the invisible force holding all of our heavy infrastructure together. All right, let's switch gears and talk about the new kid on the block: laser welding. And honestly, if traditional welding is like a powerful sledgehammer, then laser welding, that's a surgeon's scalpel. So LAS is actually an acronym, which kind of hints at its power. Instead of that broad electric arc we just talked about, this method uses an incredibly focused high-energy beam of light to melt the metal. And this one change, going from a wide heat source to a tiny pinpoint one, it completely changes the game. And here it is, the single most important difference. Traditional welding creates a big, what's called a heat-affected zone, or haze. All that extra heat can sometimes weaken the metal around the weld. But the laser's focused beam, it creates a teeny tiny haze, and that means less distortion and a stronger final product, which is absolutely critical for delicate materials. That small heat zone leads directly to some pretty amazing advantages. With less heat, you get way less stress and warping on the material itself. This lets you work incredibly fast, with pinpoint precision, and you can even join really thin or sensitive parts without any risk of damaging them. And you can see these strengths reflected perfectly in where it's used. Laser welding is the absolute champion in industries where precision is everything. We're talking about assembling life-saving medical devices, critical automotive components, and even crafting the incredibly intricate details you see in fine jewelry. All right, we've met the contenders. Now it's time for the main event: the head-to-head comparison. Let's really see how they stack up against each other across the factors that matter most. So, does the insane precision of the laser just make traditional welding totally obsolete? Or does the old school, tried-and-true method still have a few tricks up its sleeve? Let's break it all down. Okay, this table really lays it all out, doesn't it? When it comes to precision, a smaller heat zone, less distortion, laser welding is the clear winner, no question. But then you get to that last row, and that's a big one. Traditional welding has a huge advantage when it comes to the initial investment cost. So, as you can see, there is no single best method here. It's not about which one is better in a vacuum, but which one is the right choice for a specific job. So, how in the world do you decide? Really, it boils down to a pretty simple trade-off. Do you need a cost-effective, versatile workhorse that just gets the job done? You go traditional. Or do you need surgical precision for a delicate, high-stakes task where there's no room for error? Well then, the laser's your answer. And this right here, this says it all. The final decision really just hinges on your specific application, the project itself, and of course your budget. It's all about choosing the right tool for the right job. So the next time you look at how something is made, think about this fundamental choice. Is it a game of pure precision, where every single micron matters? Or is it a question of budget and just practical, rugged strength? For any project, the answer to that question is going to determine not just the process you use, but the final outcome you get.